We've used the term expected value a few times. Expected value is a term used in statistics, which means the probability of winning times the amount you can win minus the probability of losing times the amount you must bet to see if you're going to win. If you take a look at this graph, this shows you the expected value formula. A positive expected value is good. It means over the long run, you're going to win more than you're going to lose. A negative expected value is bad. Over the long run, you're going to lose more than you're going to win. Expected value is used extensively from now on to put you in a positive expected value situation and keep you out of negative ones. You're going to win more and lose less using expected value. Later, you're going to see a graph showing you how many bets must be in the pot before you should bet. One question I get asked often is if the probability of catching specific cards doesn't change, why must we have a certain number of bets to stay in the hand? Let's go through an example. To make this example easier to understand, we're going to ignore the rake. We have our 4 flush again on the flop. What's the probability of making the flush on the turn? Our probability of catching is equal to the number of cards left in the deck to make the flush divided by the number of cards we don't know. 13 minus 4 divided by 47 equals 0.19. The probability of not catching is 1 minus the probability of catching. 1 minus 0.19 equals 0.81. So far we know several parts to the expected value equation. Expected value equals 0.19 times the amount we're going to win if we win, minus 0.81, which is our probability of losing, times the amount we must bet. In this example, we'll assume no one is raised, so it will cost you 1 bet to call. Our expected value equals 0.19 times the amount to win minus 0.81 times our 1 bet. Now here's where the pot size comes into play. If the pot had 3 bets, your expected value would be, take a look at this graph, 0.19 times 3 bets minus 0.81 times 1 bet equals minus 0.24 bets. You've got a negative expected value of minus 2.24 bets. That means if you played this hand thousands and thousands and thousands of times, you would, and I would, if I played it, lose an average of 0.24 bets for every hand we played. This is not a good deal. Well, how about if there are 4 bets in the pot? Let's go through the same thing. It's the same equation. The only thing that's changing now is the number of bets. 0.19 times 4 bets minus 0.81 times 1 bet equals minus 0.05 bets. Expected value is still negative. This is not good. We need a positive expected value. Okay, if there are 5 bets in the pot, same equation. The only difference now is that we now have 5 bets in the pot as opposed to 4. And look, lo and behold, we've got a positive expected value. Yoo-hoo! 6 bets? Wow, a bigger positive expected value. 7 bets? Even more. If there are 7 bets in the pot, our expected value is a positive 0.52. If we're at a 10-20 limit table and there are 7 bets in the pot on the flop with our flush draw, the amount we could win with the pot is $70. If we call and nobody raises, it costs us $10. Assuming we win with our flush, that means if we played this hand the same way thousands and thousands and thousands of times, we would win 0.252 times our bet, or 0.52 times $10, or on average, $5.20 for every hand we played. That's a good deal. It doesn't mean we're going to win every time or close to every time. But as long as you base your play on positive expected value, you will win over time. Well, what's changed in our example? Has the probability of us getting the flush changed? Nope. The probability is exactly the same. The only change that has occurred is the amount in the pot, and that in turn changes the expected value. What's the relationship between pot odds and expected value? Does it matter to your car if you fill it up with gallons or liters of gas? Well, just as odds and probability are the same thing of saying the same thing, in a different way, so too are pot odds and expected value. Anytime the pot is offering you more than your odds against, that means the same thing as a positive expected value. Whenever you have a positive expected value, that means the same thing as the pot is offering you more than your odds against, gallons or liters. Do we use pot odds or expected value? Daniel and most poker players use pot odds. But I'm going to use expected value because it is simpler for my mind to grasp and simpler for a lot of my students to grasp. Simpler is better for some people. I won't use the term pot odds much anymore, but when I do, it means exactly the same thing as expected value.